Welcome to Chapter 9 of the Quick Terrain Modeler Getting Started tutorial series. In this module, you will learn how to import point data and create surface models, also known as digital elevation models, digital surface models, and digital terrain models. We will be using the Iowa Des Moines LiDAR data in this video, so feel free to visit appliedimagery.com/download and download the zip file containing the Des Moines LiDAR data and imagery. The difference between importing and loading or simply opening an LES file is that you have the ability to create a digital elevation or surface model from a point cloud, whereas loading simply displays the point cloud from the LES file. Other reasons to use the import function are when something needs to be done to the data prior to loading it, such as filtering point cloud data by attribute or return number, or decimating data, a process to reduce the number of points. Or when you are working with non-standard data file formats such as ASCII data, for which the user must specify the structure of the data prior to importing it. Another reason could be when you are working with more obscure data formats that may not open but can be imported once the data type is selected. And lastly, when a 3D surface model format is completely unfamiliar and nothing else works, it can be helpful to attempt to import as GDAL supported DEM to tap into the GDAL open source libraries, which support many more obscure formats. As an example, and probably the most common import process, we will create a digital surface model from a single LES point cloud file. To import an LES file, select the Import Model button, or from the Import menu, Import Model. Select a source model format, in this case LES. Select the model format. We will use QTT Gridded Surface Model to create our digital surface model. The three options below the model format are generally more advanced functions. The batch import will permit users to import multiple data sets at one time, repeat a specific import process, or build many models that, if loaded together, would overflow existing memory. The Allow Compressed Data option allows a trade-off between model precision with file size, and the Access Data in Proxy mode is an optional import setting that allows manipulation of much larger point cloud models than will fit in memory. Click the Import button and the File Selection dialog will appear. Select the desired file and select Open. The LES Import dialog will open and is separated into four sections: Processing, Gridding, LES, and Georegistration options. For this example, we will set the options as follows. Since we are processing a single LES file, we will leave the processing option set to process individually. For gridding options, we will set the grid sampling to the nearest meter from the Qt Modeler recommended grid sampling. In this case, 1 meter, which will result in a 1 meter digital surface model. We will leave the decimation, crop options, and gridding options set to the default. And the Allow Rotated Grid defines whether the model will be oriented to grid north-south, or allow Qt Modeler to orient the grid in the optimum fashion to minimize file size. In the LES options section, most selections are best left to the Qt Modeler defaults. Show LES Header Info displays information contained in the header of the LES file. Total Points shows the total number of points in the source LES file. Desired Return gives the ability to import by a specific return number, 1, 2, 3, 4, 5, or last. Import Intensity, check this box to include the LES file intensity values in the vertex colors of the new model. Import RGB is similar to the import intensity but displays color values, if available, in the LES file. Intensity and RGB are mutually exclusive. Choose one or the other, but not both. Filter by classification we will leave set to the defaults. Trust header extents include withheld points and include synthetic points we will leave set to the default. In the georegistration options, if no other model is loaded, the current global coordinate system will be unknown, and unless you want to change the native coordinate system of the incoming model, leave the default values. After you select Go, the model will load. Don't forget to save your model as a qtmodeler.qtt file, or, if desired, export the file in the universal standard format that most all geospatial programs recognize by right-clicking on the model in the layer tree and selecting Export to GeoTIFF DEM. Name and save the file. In closing, here is the original LES point cloud file on the left and the digital surface model we just created with overlaid imagery shown on the right. This has been a brief overview of importing point data and creating a surface model. Thank you for using Quick Terrain Modeler, and please contact us if you have any questions or suggestions. We'd love to hear from you.